ID number of BA17058. So for my part, I'm gonna do explaining the coding. Okay, straight away into it. So starting from here to here, this is all the declarations for to initialize the system, whether it is ready or not. And for this part, this is the declaration for text for SMS. I'll use temp for temperature, humi for humidity, and for this part, this is the connection for the hardware, where the smoke will be connected A0, LED 1, 13, LED 2 at port 12. And then for this part, this is the sensor threshold. The functions of this sensor threshold is, it is the limit whether should be alert or not. And then for this one, and then for this one, for the declaration for my servo, same as this one. And then right here, it is the SIM card for the GSM, which will appear the number of the SIM card. As for our case, we're using 016942 and 0068. And moving on to here, entering the process, the pronounce, which is the LED 1 is the output, the same as LED 2 is the output as well. And when we take smoke, is the input. And for this part, it is to make sure whether the system is ready or not. This will appear on the serial monitor, which is Pona Semester ID test, initializing, and then if the process, if there is no problem in the system, it will pop out Pona is okay, and if it is not, it will pop out couldn't find Pona. So night 30, it will pop up Pona ready right here. And then the process, it will read. So right here, it will read the humidity. For this part, it will read temperature. After reading it, the serial monitor will pop out the reading for humidity, the temperature. The temperature will be in degrees Celsius. And then for this one, after combining all, it will the sensor of the smoke, it will appear here. And then for the smoke, there would the measurements of the threshold, whether they're past 400 or not. If the sensor measurement exceeding 400, the GSM will send the message to the homeowner, your house is on fire. So the same, this is for it will pop up the LED 1 high and LED 2 low. If not, if this other case, it will be LED 1 will be low, LED 2 will be high. And then this is the instructions for the servo motor. The servo motor will activate the sprinkler. And then after testing all this coding, we get the testing result. For the testing result, okay, here, testing result, it will, okay, the system will initialize. We'll look at the pop out here, everything is okay, and when the system is okay, it's okay. And then when it's ready, it will pop out when it's ready. And initially, the surrounding humidity is 73.6 and temperature 28.6. The sensor detects, and the sensor is at normal, which is under 400, which is 248. But then, when there is fire, the sensor measurement is 403. 403, as known, has passed has passed the threshold, which will trigger the GSM to send message and activate the servo motor. And then here is failed because we haven't entered the homeowner's number. If we fill the homeowner's number, it will send the message. And here is the measurement. Okay. After it has reached the exceed threshold, the homeowner will receive text message like this, which determine which an alert system your house is on fire. That's all for my part. Thank you.
Hello everyone, my name is JANETHY JURIN and I will be explaining the Proteus simulation of our project. As constructed in the circuit here, this is our LCD, serial monitor, the gas sensors, the LED indicators, both red and green, the Arduino, the servo and the temperature sensor. And once we run our simulation, we may see that the LCD will display the current temperature as well as the current situation, where the green LED light is also on. Even though the current temperature has exceeded the threshold value, the gas sensor doesn't detect any smoke, thus concluding that there is no fire detected. However, when the gas sensor does detect smoke, the program will conclude that there is fire and the red LED light will be on, as well as the motor will be triggered in order to stop the fire that is detected. And if we put the value of the temperature lower than the threshold value, which is under 26 degrees Celsius, the program will display that there is no fire detected and the green LED light will be on, even though there is smoke detected by the gas sensor. And as you can see, the motor is also not moving. Thus, our simulation has successfully done its part in the end equation of the fire detection of smoke through smoke and temperature.
Hi, my name is Sheng and I am in charge in hardware construction. So the component that we used for hardware construction are MQ2 smoke sensor, 9V 2A power adapter, DC to DC step-down voltage regulator, Arduino Uno, SG90 servo motor, DHT22 temperature and humidity sensor, and GSM 900A. The reason that we use 9V 2A power adapter and DC to DC step-down voltage regulator is because GSM SIM 900A require 5V 2A voltage and current as input. So we need to use 9V 2A power adapter to supply 2A to GSM SIM 900A and use DC to DC step-down voltage regulator to step down 9V to 5V. For circuit construction, I use EasyEDA to construct my circuit so that it will make my wiring process more easier. To ensure that this prototype will become more successful, so I decided to build the component on a breadboard before I proceed into prototype. So this build is to test and ensure components are all working at the same time. To explain how this project works, initially the green light LED will turn on to show that this house is in good condition. After smoke detected, it will trigger the red LED to turn on and water sprayer is activated, and a message will be sent to the owner to show that this house is on fire. So this is the hardware prototype that I designed. As you can see that I use PVC cardboard to make the casing is because PVC cardboard is more durable than basic cardboard. So without further ado, let me show you how this prototype works. Let's watch the video.